there. So what we're going to do for starting chapter 6 is you're going to have the two days to work on this first topic. You've got 2 presentation problems and then some odd additional practice. And just do some of these on Monday, some on Tuesday. Then you're going to have a long weekend. This is a fantastic opportunity, Wednesday through Sunday, to catch up on some of the missing assignments that you maybe have in my class or some of the others. If you don't have any missing assignments for me, fantastic. Chance to do maybe a correction or 2. Or, again, focus on another class's work that you do have missing assignments in. I will still be answering my email Wednesday, Thursday, and Friday, though because I'm preparing for hybrid for my middle school classes, it might not be just quite as quick as I've been able to get back to you in the past, but I will definitely get back to you within 24 hours, either way. Then, so you're not going to have a quiz this week, just working on 6.1, and you will have a quiz on 6.1, 6.2, and 6.5 on Friday the 23rd. So, get yourself ready for notes, and we're going to get started about finding the area between 2 curves. So, if you look at this picture here, we can see that we have an upper curve here, which is f of x, and a lower curve, g of x, and we can use an integral to find the area between these 2. Now, if you're not sure which is the upper bound of the curve and which is the lower, and you have a calculator, you can plug in absolute value here. Or if you do know, all you want to do is set them up as a subtraction problem where you have f of x, the upper bound, right? It's above the area here, minus g of x, which is the lower. And so that's the lower part of the curve here. Don't worry about the fact that it crosses the axis. The subtraction will take care of that just fine. From A to B. And that gives us our bounds of our integral. Now, sometimes you won't have bounds of the integral. So let's look at number 1. Find the area between y is equal to 5x minus x squared and y equals x bounded by the curves. So what I will often recommend as the first thing to do is either using your knowledge of graphs or your graphing calculator is take a look at the area you're trying to find. So the first function here, y equals 5x minus x squared, is going to be a parabola. It's negative parabola, so it's going to look like this, going from the origin to 5 as its 2 roots. And y equals x, hopefully you don't need a graphing calculator as much to graph the line going through the origin here, so that the area that you're trying to find is this section right there. Now, the bounds of this section are going to be the intersection points, and they're on the x-axis. This one is nice to find. It's 0. The other point here we have to find, and that's going to be the first thing, is that if not given, find the bounds of the region. Sometimes they'll be nice and say, okay, between x equals 2 and x equals 10. If they don't, you need to find them because they are often going to be the intersections of the curves. Now, if you remember to find intersections, what you want to do is set the equations equal to each other. So in this case, 5x minus x squared is equal to x. Now, it is a quadratic, so I'm going to set them equal to 0 and factor. So in this case, I'm going to say 0 is equal to x squared minus 4x, because I'm going to add over the x squared and subtract 5x. So then 0 is equal to x times x minus 4, which tells us that our intersections are at x equals 0, which you can see nicely in the picture, and the other one is at positive 4, giving us our 2 bounds. Now, the next thing you want to do is, because we've graphed it, is you want to identify the upper versus lower curves. So in this case, the parabola is the upper curve, and the line is the lower. So what that tells us here is that we are going to want to have the parabola 5x minus x squared minus, that's our f of x if you consider this picture over here, that's our upper curve, minus the lower one, which in this case is the line, like so. Now, all you need to do from there is integrate. So I'm going to start my integral all the way over here to give myself a little bit more space. So my bounds are 0 to 4, which are the intersection points, and then 5x minus x squared minus x dx as our equation there. I'm going to start by simplifying into a single polynomial. So then I get 0 to 4 of 4x minus x squared dx. Use my anti-power rule to get the integral, which would be 2x minus 1/3 x cubed, 2x squared, apologies for that, from 0 to 4. Now when I plug in 4, I get 2 times 4 squared minus 1/3 times 4 cubed minus 2 times 0 squared, which is 0, minus 1/3 0. So I'm just going to not worry about that 0 term. So then I have 2 times 4 squared, which is 32, minus 1/3 times 4 to the third, which is 64 over 3. So my final answer is 32 over 3. You could also have written it as a mixed number or a decimal, but I don't see the point of adding that extra step. So again, find the bounds or the intersections if they're not given, identify upper and lower so you can set up the difference, and then integrate your steps there. Let's do another practice. Find the area between sine of theta and cosine theta from 0 to 2 pi. So again, I'm going to start. Here they do give us the bounds. They're asking from 0 to 2 pi. And when we graph our two functions, I'm going to start with sine. So sine goes up, back down, their amplitude of 1, -1 here. So that's our sine on this interval. Cosine starts at 1, has a minimum, back up, back up. Now, we're looking for the area between these from 0 to 2 pi, so we're looking for this area, this, and then here. Now, while this is not the neatest of diagrams, one thing that's tricky is you're like, oh, we've switched from upper to lower. So for example, cosine's the upper here, then it becomes the lower one, then it becomes the upper one again. So we have to switch back and forth between sine and cosine, very challenging. Have to write basically 3 different integrals if you wanted to do this like that. You absolutely can. I am not going to. What I am going to notice is that this shape here, if I kept going on, I could put that here, and we see that we have 2 symmetrical curves. There's a symmetry here that the split up area is equal to the same as the joined area. So the total then, I'm just going to say, is 2 times the area from this intersection point here to this intersection point here. And in that case, sine is the upper bound minus cosine, which is the lower bound on this interval, d theta. So now all I need to do is find a and b. Now, this is when sine of theta is equal to cosine of theta. And if we think about the unit circle, that happens here where they're both positive and here where they're both negative. This is pi over 4, because remember it goes straight through the center. And so this would then be pi plus another pi over 4. So that is 5 pi over 4, which tells us that our a and b are pi over 4 and 5 pi over 4, like so. So now my area is 2 times the integral from pi over 4, 5 pi over 4, sine theta minus cosine theta d theta. I've got everything set up, and so I can jump straight to my integrals. So the integral of sine is negative cosine. The integral of cosine is positive sine. And then we're still going from pi over 4 to 5 pi over 4. Plugging in those bounds, we get 2 times negative cosine 5 pi over 4 minus sine 5 pi over 4 minus cosine pi over 4 minus sine pi over 4. Using our unit circle here, we know that these will become root 2 over 2 for all terms. So this becomes 2 times root 2 over 2. Let's see. Dropped a negative. I apologize there. Minus, plus, with the negative, root 2 over 2, minus a negative, so plus root 2 over 2, minus another negative, root 2 over 2. So that's 2 times 4 root 2 over 2, which is equal to 4 root 2. You've got 2 days to work through these problem sets and these 2 presentation problems. I will be answering emails, so please let me know if you're stuck or confused on anything there. Talk to you later.